Today is really two exponent laws. The law of exponent products and then what we're going to call power to power. Okay, so first, just kind of defining what an exponent is. So 4 to the third should be out there. 4 to the third just means 4 times 4 times 4. Do not make the common mistake of thinking that means 4 times 3, because that's not what an exponent is. It means 4 times 4 times 4, which would be what? 64, yeah. All right, so keeping that in mind, if we had 4 to the third times 4 to the fourth, we could say that is 4 times 4 times 4, that's 3 of them, times 4 times 4 times 4 times 4. That's 4 of them. So how many 4s are there now? 7 4s, right? So 4 to the third times 4 to the fourth is the same thing as 4 to the 7th. So now knowing that, what would be an easy way to get to that 7 from those exponents we had? What is that? 3 plus 4, right? If you add the exponents, we get the 7, 4 to the 7th. That is the product rule of exponents. It's if you have the same base, the base is the big number. If we have the same base and we're multiplying, we can add those exponents together. So that just becomes 4 to the 7th. Now, for purposes of simplifying it all the way out, just to make you get used to it on your calculator, we're going to put them all into the calculator. So I'm going to go down here and do 4 to the 7th. Now, if you're not aware of where it's at, just let me put that glare. The exponent button is the button above the division sign. So there's your exponent button. You press that button, it will make an exponent. So 4 to the 7th. So we're going to type all of them into the calculator, and anything, that glare again. There we go. Anything that comes out to be under a million, we're going to go ahead and simplify it. So 16,384, we're going to go ahead and write that answer out. So that'd be 16,384. Okay, that gets you used to how to type in an exponent into the calculator. Okay, the big key is the bases have to be the same. We cannot add these exponents because that base is a 4, that base is a 5. So you cannot add these exponents. Now, that doesn't mean we couldn't simplify that. We could work them out separately and do 4 squared, 5 to the fourth, and then multiply them together. But as far as simplifying the exponents, adding those together, we can't do that. All right, if we move on down, it works the same if you have variables, as long as that variable, that base, is the same. So these are both x's, so I can add 4 and 2, and we get x to the 6th. It's actually kind of easier with it when you're dealing with variables because we are always done at that point. You can't go put that in your calculator. So we're just going to leave that as x to the 6th. Okay, so if you look down the examples below that, there's a little small there, but that says 7 to the third times 7 to the 6th. The parentheses, just a different way of writing multiplying. So those are both 7, so we can add the 3 and the 6, and you get 7 to the 9th. So if I go see what that one is in the calculator, it comes out to be well over a million. It comes out to be, what, 40 million. So we're going to leave that answer as 7 to the 9th. That way I'm just trying to avoid you having to write out too long a number. Next one, these are both 3's. 3 to the third, 3 to the 8th. So 3 plus 8, that becomes 3 to the 11th. Let's go see what that one is. 3 to the 11th. 177,147. So we will write that one out. So 177,147. Third one there. Glare goes away. There we go. Can you add those exponents? No. So I'm just going to write cannot add exponents. While we're on that, look at the one below that. Can you add those exponents? No, because it's an x and a y. I'm going to put an arrow to both of those. We go down to the bottom left now. We got x to the 5th times x to the 9th. So 5 plus 9, we get x to the 14th. And then also, it doesn't matter how many terms you're dealing with. As long as these are all a's, I'm going to add up all the exponents. So 3 plus 8 is 11, 11 plus 4, and we get a to the 15th. All right, now most common mistake with this rule is this, and it's something real simple. What would that be? X to the what? 5. What's the exponent here? There's nothing written there. It's a 1. So until you get used to it, if there's no exponent written on it, put a 1 there. That way you won't make that mistake, because it's really easy to make that mistake. But if you write the 1 there, it's really easy to not make that mistake. So get in the habit of putting that there until you get that down. All right, so that is our product rule. When we're multiplying with the same base, we add the exponents. If you move over to the top right, this is our power to a power rule, meaning we've got an exponent raised to an exponent. Okay, so if I have 5 squared raised to the 4th, what that means is 5 times 5, 4 times. So 5 times 5 times 5 times 5, 5 times 5, and 1 more, times 5 times 5. So if you count up the number of 5s there, how many have? 8, yeah. So that becomes 5 to the 8. So once again, knowing that, look back at the original problem. How could we get to 8 easier from those exponents? Yeah, multiply. So with the power to a power rule, you multiply the exponents together. So if I have x to the 4th raised to the 3rd, it becomes x to the 12th. Okay, so those are the 2 rules we're looking at today. Power of power and then the exponent products. Okay, same thing here. X to the 3rd raised to the 6th, 3 times 6, 18. And I'm just writing it out once. You don't have to write it out twice if you don't want to. All right, same rule as far as simplifying it if it comes out to be less than 1 million. Okay, so if you move down to these examples, 5 to the 2nd raised to the 5th, 2 times 5, so 5 to the 10th. If we go check that one in the calculator, comes out to be over 1 million, 9,700,000 something thousand. So we will leave it as 5 to the 10th. Next one, 8 to the 4th raised to the 2nd. So 4 times 2 to the 8th. Yep. See what that one is in the calculator. Once again, over 1 million, 16 million. We'll leave it like it is. Next one, and there's the glare again. Let's see if I can do it. Yeah, x to the 12th. That's 4 times. Ooh, that's not good. There we go. 4 times 3, so x to the 12th. All right, it's back again. Next row, we got 3 times 9. So 3 to the 27th. I imagine to that big of an exponent, it's probably a huge answer. So let's see. Yes, comes out. If you see that E, that's scientific notation, which we'll get to later on. Just know that that means it's a huge number. It's way over 1 million. So we'll leave it as 3 to the 27th. And then 11 times 6 should get a to the 66th. And then the last one should become x to the what? 7. Good. Right, so really the only tricky part comes in is when you're dealing with both of them at the same time, remembering which rule is which. So just being able to recognize the difference between that and that. So this is our adding rule. For multiplying with the same base, we add those exponents. So that become a to the 16th. The right column, that's your multiplying rule. 5 times 11, a to the 55th. The easy way to recognize the difference, when you're multiplying, there's an exponent right outside the parentheses. That's when you're going to multiply them. So the next row, 2 plus 9, that becomes y to the 11th. This one we're multiplying them, 2 times 9. So y to the 18th. And then third row, add these exponents. So 13 plus 5, 18, and then multiply these. And that should give you 65. So x to the 65th. You good so far? All right. We'll look it over. Just going to work through these examples together. And I'll touch you with some homework. What time do we get out of here on this schedule? 27? Okay, good. All right, top left there. Now we got coefficients mixed in with it. So when you're looking at this, that 5, I would multiply it by another coefficient if there was something in front of this x, but there's not. So there's just going to be a 5 in my answer, and I'm adding the exponent. So 4 and 7, x to the 11. Okay, so keeping that in mind, we move to the one to the right of that. Now they both have coefficients. So you go ahead and multiply those. 9 times 5, 45, and we're adding the exponents. Since they both have x's, 3 and 3, x to the 6th. If it makes it easier, you could rewrite it like this. It means the same thing. 9 times 5 times x to the 3rd times x to the 3rd. That means the exact same thing. That 9 and that 5 aren't necessarily have to be connected to those variables. Sometimes that's visually easier to look at. Okay, next row. This is your power to a power rule. What is the exponent on both the 4 and the a inside there? 1. So if I multiply that in, 5 times 1, now I have 4 to the 5th, a to the 5th. And then last thing we're going to do is just see what 4 to the 5th is. And it's 1,024. So that would become 1,024 a to the 5th. Okay, similar to that last one. What's the exponent on the a and the b again? 1. The 4 is outside the parentheses. It's going to have nothing to do with that exponent. So the 4 is just going to stay there. And now we have a to the 5th, b to the 5th. They each have that exponent of 1, both the a and the b. So they each get multiplied by that 5. Third row there. Once again, the -3, the x, and the y all have an exponent of 1. So we're going to multiply the 4 by each of them. That's going to become -3 to the 4th. And when it's a negative number, put it in parentheses, because we're raising the negative to the exponent also. And then x to the 4th, y to the 4th. All we have left now is to work out -3 to the 4th. When you have a negative number raised to an exponent, make sure you type it in with parentheses to your calculator. Otherwise, you're going to make some mistakes. So that gives us 81. So it becomes 81, x to the 4th, y to the 4th. The one to the right of it looks the exact same except what's it missing? Doesn't have the negative, right? So we should get the same answer. So we're going to have 3 to the 4th, x to the 4th, y to the 4th. Now, why did these come out to both be positive 81? If I have a negative number, negative times a negative is a what? Positive. So as long as my exponent is even, 2, 4, 6, 8, that's going to give me a positive answer. Okay? So it turns out to be the same thing as positive 3 to the 4th. But if it's an odd exponent, this is where it can be mistakes in the calculator. Let's say I want to do -3 to the 3rd power, and I forget to type, or no, it's about even. Hold on. -3 to the 4th power. So if we type that in the calculator without parentheses, it's going to tell me my answer is -81. It's not. It should be positive 81, which we got over here. The reason why is when you don't put that negative in parentheses, the calculator reads that as this, -1 times 3 to the 4th. It's only raising the 3 to the 4th. It's not raising the negative. So that's why anytime you got a negative, make sure you put it in parentheses. And it's a good habit even with other things besides exponents, just to put it in parentheses. All right, next row. You will have one just like this on your quiz Friday. You'll have one just like this on your test next week. It's very simple. Everyone always makes it way harder than it is. It's just a power to a power problem. 2 times 4 is what? 8. So it just becomes x plus 1 to the 8th. That plus in there, it makes it like its own term. That might as well just be a variable by itself. That's all you have to do on that one. You don't have to now take that inside the parentheses. Just leave it like that. Right, moving over to the right, now we're kind of combining multiple problems within one. Just like distributing, which has to happen first, if you see a power to a power rule, that has to happen first, because it's like distributing an exponent. So forget this second part's even there. We're just looking at that. So we're going to have negative 10 to the second power, because on the negative 10, the exponent's a 1. And then x, 6 times 2, which gives us what? 12. Okay, now you can bring down the times x squared and simplify what you have left. So negative 10 squared, negative 10 times negative 10, would be 100. And add your exponents, because these are both x's, so 12 plus 2, and we get 14. So 100x to the 14. Okay, bottom row on the left. This is what I was showing you on the front side earlier. Don't forget that y has an exponent of what? 1. So it's 3 plus 1 plus 4, which is going to give you y to the 8th. And the last one on the left side here, power of a power rule. So what do we do with those exponents? Multiply them. So that becomes 9 to the 21st, and save your time. You don't even put that in the calculator. That comes out to be a really big number. All right, right side now. So x to the 5th times x to the 2nd. What are we going to do with those exponents? Add them. So it becomes x to the 7th. Okay, same thing over here. It's just 3 terms. So they're all a's. 10 plus 2 plus 6. And we should get a to the 18th. Second row there. The negative 3 and the x both have an exponent of 1. So when you multiply the 4 in, we now have negative 3 to the 4th, x to the 4th. And then to simplify that, we just did it right here. Negative 3 to the 4th gives us 81. So 81 x to the 4th. Over to the right, this is the one that I said be on your quiz and your test that everyone misses. All you have to do there is what? Yeah, it's the power to the power. Multiply those. So b plus 1 to the 6, 3 times 2. Okay, third row, 2, the a, the b, all have an exponent of 1 again. So they're all going to become 2 to the 5th, a to the 5th, b to the 5th. And then we go to the calculator and see what 2 to the 5th is. It should give you 32. So we end up with 32, a to the 5th, b to the 5th. Alright, so the one to the right, it's kind of like the bottom right on the left side of there. It's a challenging one. What do we have to do first there? Yeah, multiply that 4 in. So there's a 1 on the 3. So that becomes 3 to the 4th. And then m, 7 times 4, 28. And then just bring down the times into the third. Once you do that, it kind of starts to look a little easier. So 3 to the 4th now, you put that in your calculator, you're going to get 81. And then what do we do with these exponents? Add them, because they're both m's, so 28 plus 3. We get m to the 31st. and your last row. Power to a power again. So just don't forget that 2 and that y have an exponent of 1. So 1 times 6, that becomes 2 to the 6. For the x, 6 times 3, 18, and then y to the 6. That's all we have left. Go work out 2 to the 6, and that gives you 64. So 64, x to the 18th, y to the 6th. And then the last one there, just like the one above it. You have to take care of that multiplying with the power to a power first. So I'm just going to bring down the 4p squared. Not do anything with that yet. So I'm going to have 3 squared, then p, 5 times 2, so to the 10th. Now before I can multiply that 4 and this, I got to go ahead and work out 3 squared. So what is 3 squared? 3 times 3. 9, yeah. So the second step, that's all I'm doing. I'm just working out the 3 squared. So now you can multiply 4 times 9, get 36, and then add these exponents. 2 and 10 on the p's give you p to the 12. Alright, now, it can be a little time consuming, but if you're ever not sure you did it correctly, there's a very simple way to check these. Just give the variable any number you want. Like I'm going to use this last problem as an example. I'm going to say p is 1. I'm going to go type that in a calculator. Let me get both on here. Just like it says there, but everywhere there's a p, I'm going to put a 1. So times 3, 1, to the 5th. Raised to the 2nd. And I'm going to see what answer that gives me. That gives me 36. If I did it correctly, I should be able to go take 1 and plug it in here and get the same answer. And I think we can tell it's going to give us the same, right? What's 1 to the 12? 1 times 1 times 1 times 1 over and over again. 1, right? 1 times 1 times 1. Doesn't matter how many times it is. 1 to any power is 1. So we had 1 times 36. And we get 36. So that is the one way you can check it. And when you do that, pick an easy number, like I did, like 1. Don't go plug in 37. It's going to make a lot more work for you. Does that make sense? All right, so your homework's going to look just like that. So really that's 2 of the 3 topics that are going to be on your test next week and on your quiz Friday. The multiplying and power to power. Tomorrow we're going to do division. Let's do the evens for homework on here. And as always, you can do all of them if you want for basic points. You might want to do on here.